written a program for your cell phone, for your mobile. So nobody in this room has, or maybe Lionel, you've written one. So, I mean, that's something that's changed with the Apple and the Google model. That people are starting to write programs for phones, whereas before that was only something that the phone company could do. Now it's starting to happen, but then there's a follow-up question, which is that when you write your program for your phone, do you do it on your phone? Or do you do it on a computer? You write your program on the computer. The affordances, the physical affordances of this device are suitable for being expressive. They're suitable for consuming content, but not creating content. You don't write an essay or even a poem on a phone. You might write a text message, but that's about it. You might shoot video with your phone, but you don't use your phone to edit video. You don't use your phone to write programs. So there's a limitation here that we can begin to exploit here that can be a real difference. That can be the real differentiator, is the difference between being a consumer and being a creator. And that's really the opportunity that we're trying to pursue with Sugar and with the software tools we've been developing. And I think that distinction, consumer versus creator, is the big opportunity, the big differentiator between netbooks and mobile devices in general, the smartphone. The smartphone still is fundamentally a tool of consumption, not a tool of creation. And that's the opportunity that I think we have to seize as an industry. So, there's got to be more than ebooks, and I'm suggesting that this tools of expression is it, and that's my segue into talking a little bit about Sugar, because that's exactly what Sugar's about. But before I get into that, to part two, I want to do a little exercise. You know, it's early, we've had a little bit of coffee, a little bit of conversation, but most of you look like you're still asleep. And so I want to get you thinking a little bit and work you a little bit. And so what I want to do is I'm going to challenge you. I've got a little mathematical puzzle, and we're going to work through this mathematical puzzle together. And there's a reason for this, so bear with me. So it's a number sequence. And the number sequence starts off quite simple. It's 0, 1, 2. Pretty easy number sequence so far. And you might guess that the next number might be 3. Well, it isn't. It's a good guess, but that's not. The next number in the sequence is 720 factorial. Okay, so 0, 1, 2, 720 factorial. What comes next? And what I want to do is I will remind you that 720 factorial is 720 times 719, all the way down to 1. Very big number. So, you know, it's a nice, you know, we're just sort of walking along 0, 1, 2, and then boom, we just take off 720 factorial. So, now, some of you probably come from engineering backgrounds, and then some of you probably don't. And for those of you who come from engineering backgrounds, the number 720 might be familiar. But for the rest of us, 720 is a reach. So for some people, this fact, that 720 is equal to 6 factorial, is low shelf. I don't have to go far to get it, it's there. For most of us, you know, reach way up to the high shelf to find that. So I want to make a distinction between things that are close at hand, low shelf, easily accessible, and things we really have to stretch for, things we have to reach for. So again, 720, 6 factorial, 6 being 3 factorial, 720 factorial is 3 factorial, factorial, factorial. And so the answer to the puzzle is simply this. So 0, 1 factorial is 1, because it's 1 times 1. 2 times 1 is 2, so 2 factorial is the same as 2. So 2 factorial factorial is 2. We just figured out that 3 factorial 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 is 720. And then the next number in the sequence is 4 factorial 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 factorial. So, how many of you instantly got that? Well, maybe a little more coffee and you would have... But again, so the distinction I want to make, again, is if you knew that 720 was 6 factorial, which some people know, to some people that's easy, to most people that's a stretch. Low shelf, high shelf. I want computation to be in every child's low shelf. So the goal of Sugar, which is the software that we originally wrote for one laptop per child, but that runs on every computer, is to give every child tools, things to think with. And there's nothing more powerful in terms of a thing to think with than a computer. And so what we're trying to do is, again, make computation and the thinking that goes with computation be every child's low shelf. That they don't have to stretch to use these tools, but it's there for the taking. Now, my goal is not to turn every child into a computer scientist. That's not the point. But it's the thinking behind computation that I want them to adopt, that I want them to have a grasp of. It's the problem solving associated with computation that I want to have low shelf for them. And so I'm going to talk a little bit about how we try to achieve that with Sugar. So, part 2 is Sugar. And again, it's a learning platform. It's a free software platform that was originally developed by one laptop per child. And then actually not much more than about a year ago, we spun out of one laptop per child. And actually last year was really the first time I spoke publicly as the founder of Sugar Labs last year at this conference. And I've got another announcement this year. But what we did is we decided that this is a great tool, but so is this, so is this, so is this, so is this, so is this. What happened was that one laptop per child was one of the innovators in terms of launching the netbook market. But the netbook market has taken off. And the software we developed for one laptop per child doesn't need to just run on that one device, but actually should run all these devices. Because our goal is not to sell little green and white laptops. Our goal is to reach every child with an opportunity for learning. And so if Intel's going to reach children, I want to be there. If Dell's going to reach children, I want to be there. If NEC is going to reach children, I want to be there. So we want to be able to give this opportunity to every child, no matter what device they have. So, the context is culture, not technology. I'm trying to change the culture of school, and I'm trying to change the culture of computing. I'm trying to convince teachers what they already know, but it's been suppressed. And what teachers already know is that learning is something that everyone does, all of their lives. And that learning is action. Learning is doing. You learn through doing. So if you want more learning, you want more doing. And the computer and computation are this wonderful opportunity for doing. And what I want to change about the culture of computing is that computing, unlike the phone business, computing is not a service. Computing is something that you take a much more active role in. You don't just use the computer to consume, but you use the computer to create. And free software is fundamental to that. Because if it's not free, if it's not open, you're prevented, you're precluded from being an equal participant in the creative process. So there's a cultural battle, not a technological battle. The technology we have in hand. The world is doing that. Sasha was telling us about all sorts of great innovation that's happening on the technology front. It's a cultural question that we have to address. It's really understanding, what is this thing for? What's the message we're sending when we give people technology? Are we giving them a message of consumption, or are we giving them a message of production, of creation? And again, knowledge, and most of school is about knowledge. It's about collecting little objects. And once you've got enough objects collected, these little knowledge objects, you take the exam and you pass, and you're referred to as educated. But knowledge isn't learning. Learning is a verb. Learning is doing. And learning is not just doing, learning is doing with some passion. Love is a better master than duty. And so learning is really about doing things that you're passionate about. And again, the computer is something that is able to capture and hold our attention. And the reason is because it allows us to engage in things we love. It doesn't tell us what to love, but allows us to amplify those things. And so what we're trying to do with sugar, and what I will argue is the opportunity for this industry, is doing. Giving people opportunity for doing, for making, expressing. So let me just give a quick overview of sugar itself, and I'll be fairly brief. Sugar is a child-centric interface. What we did was we threw away Windows, quite literally. The Windows metaphor, the desktop metaphor, was invented by Xerox back in the 1970s. And who was their audience? Xerox designed it for office workers. But they didn't design it for office workers of the year 2009. They designed it for 1970-style office workers. That was their target. Now, what does 1970-style office work have anything to do with today? Nothing. And then, if you think about what does 1970s-style office work have anything to do with our children's future? Even less. And so, when we were trying to rethink what is the learning experience on the computer, the first thing we did was we challenged the basic assumption of Windows and the desktop metaphor. Is that really the appropriate metaphor? Is it about pushing documents around? Or is it really more about, again, giving people tools of expression, giving people tools of doing? So in sugar, we have this concept of you in the center, the actions, the activities you engage in around you. And we don't talk about just applications, we talk about activities. Because an application is just a tool. The activity is using the tool and all the things that are associated with its use. And the things that are associated with its use are not just creating things, but the things that you create might be saved somewhere, they might be shared with other people. So there's a whole set of things that happen when you make things that aren't just the act of making, but it's the ecosystem in which the making occurs. And so sugar really is about that ecosystem. So one of the things that sugar does is it has this concept of a neighborhood. Other users, other learners out there that you're collaborating with, that you're working with. And it also has this concept of a journal. That the things you make are saved because learning is not just doing, but it's also reflecting upon what you're doing. So we have this idea that you collaborate, engage in a critical dialogue with other people about what you're doing, and that you can be self-reflective about what you're doing. So these are the two things that distinguish sugar from just a collection of applications. It's not just a collection of applications, but it's a framework in which these applications are used that encourage certain types of behavior by the learner. And in particular, encourage collaboration, critical dialogue, and reflection. Because without those, the learning is not nearly as impactful. So, just a little bit about some of these things. So we've got hundreds of applications of activities that you can use in Sugar. We've got word processing, we've got web browsing, so the usual collection of things. And then we've got a bunch of other things that are a little bit different and kind of engaging. Lots of focus on construction, lots of focus on programming. And I'll go into a couple of those examples in a few minutes. We also have this idea called the neighborhood. And how many of you have used Google Docs? Probably everybody's used Google Docs at this point. Google Docs, for those who haven't used it, what you can do is you're in your word processor, you've written something, say, in OpenOffice, and you decide that you want to share it with someone because you want their input, you want them to collaborate with you. Now, one of the things you can do is you can just email your document as an attachment to that other person. They can make their edits, they can send it back to you, you can compare documents or do a merge and see the changes. 4 or 5 steps involved, but it works. It doesn't really take advantage of version control. Once you do that, you sort of have a binary decision. Do I accept the merges or I don't? You can do them one after another, but it's a fairly clumsy way of working in a collaborative fashion. What Google does is I can take my document and I can go to Google, I can upload it onto their server, and then I can send an invitation to you to say, here's where my document is on the server. Would you please go in and work? And now we're both working on the same document. Problem again is that there are still quite a number of steps involved, and also there's sort of this underlying assumption that we're both connected to the internet all the time. Or at least we're connected to the internet whenever we want to work. So, Sugar does it a little differently. Sugar tries to emphasize this notion of peer editing. It turns out to be a powerful pedagogical mean. But we don't do it by using a remote server and requiring you to take all these steps. What Sugar does is it lets you collaborate with one mouse click with another person all the time. You're always just one mouse click away from sharing something with someone else and having them work with you. So if I wanted to invite you to collaborate on my document, or if I wanted to have you collaborate on my presentation, as in this case, I just go to the Sugar toolbar. Actually, I go to this toolbar, and there's right here, there's a button. There's one button, and I can have my presentation be private, or I can make my presentation be shared with another person or with my neighborhood. So if I click on this now, suddenly my presentation is public. And if I come out here to the neighborhood, there's my presentation being shared. Now I'm not connected to the network. These are hotspots and I haven't connected yet, but otherwise you'd see the other people that I'm sharing with. So the idea that sharing your document, collaborating with someone else is always just one mouse click away in Sugar is a powerful pedagogical mean. And we use it in all different ways. We use it all throughout the interface. So we use it for peer editing. That's what you see here. So two students can work in the same document at the same time. You can make my corrections for me in real time with 2 cursors or multiple cursors. We use it for sharing bookmarks in the browser. So it's sort of like Delicious, only it's real time and it's always there running all the time. We use it for sharing photos. We sort of have real-time Flickr because when you're using the camera in Sugar, you can share photos directly with other students. We use it in tools like TurtleArt, so when I'm programming, I can have another student look over my shoulder and help me with my program. We use it throughout the interface as a means of sharing, a means of collaboration. Now, ironically, the only time in life where collaborating is called cheating is in school. In the rest of life, when you collaborate, you're called smart, efficient, getting the job done. It's only in school that we call collaboration cheating. So that's, again, remember I said we're sort of fighting this culture war. That's one battle in the culture war we're fighting, is that collaboration is a wonderful life skill. We want children to learn how to leverage each other's intelligence and leverage each other's skills. Now, I'll just talk briefly about the journal. The Sugar Journal stores everything. It just stores everything you do. You never hit save in Sugar, because Sugar knows you want to save. And it keeps versions of everything you do. And so it's just always there. But it's more than just a way of saving your work. It saves the things you make. It also saves the actions you took to make them. So it saves the nouns and the verbs. It saves a record of who you were collaborating with as you were making things. And you can use your journal both as a way of revisiting work, as a way of sharing your work, as a way of reflecting. And there's also a tool that allows you to make presentations from your work, sort of a portfolio tool. So when we make, we can, actually I'm doing it right now, my presentation is just drawing from my journal. I've made all these things and I'm just using them to demonstrate from the journal. So I want to make a point about simplicity, because one of the things we tried to do with Sugar, and one of the things that I think everyone's trying to do with these, is make them simple, make it easy to use. We don't want needless complexity, and again I'll argue that things like Windows represent needless complexity. In Sugar we have no double clicking. Why would you ever want to have double clicking? Actually, if you want to make sure that the elderly can't use your system, have double clicking. Because if you've got a little bit of arthritis in your wrist, you can't double click. So it's a great way to keep people out and in the complexity of double clicking. And I've been on a 30-year campaign to get rid of overlapping windows because they make no sense whatsoever. And they certainly make no sense on a small screen. So a lot of what we tried to do with Sugar was throw away a lot of the inherited baggage associated with the way we've been working, just because that's the way we've been working, not because it necessarily makes any sense. But simplicity is not the goal. The goal is learning. Okay? And sometimes learning is hard. So what we did, I want to give an example. Actually, before I give that example, we're in France, so I imagine that some of you at least occasionally have some wine. And when you go to get a nice bottle of wine, not just sort of your table wine, or you're after a nice bottle of wine, you go to the wine shop and you say, I'm looking for a really simple wine. And I don't think so. You want a wine that's got some texture, some complexity. So the goal in life is not necessarily simple. Oftentimes our goals in life are to reach to some kind of complexity, because that's where the pleasure comes from. The pleasure comes from the diversity, from the differences, from the complexity that we encounter. So with Sugar, we're not trying to make the world simple. What we're trying to do is we're trying to give children tools where they can reach to the complexity and put as many of those tools on their low shelf as possible. So reaching complexity is a goal with some simple tools. And this is an example. This is a music tool. It was written by Jean Pichet and his students at the University of Montreal. The first one in the upper left is TamTam Mini. It's a little busy box. You click on a picture of an instrument and you're playing that instrument. You hit the keyboard and you're making music. And literally a 2-year-old child can walk up to Sugar, start using this with no instruction. It's that simple. It's a very low floor. It's very easy in. But if that's all it was, if that was the beginning and the end, it would also be a very low ceiling. And with Sugar, we don't want a ceiling at all. We want low floor and no ceiling. No upper bound to what the children can do. So you go from TamTam Mini, which is a single voice, clicking away, and you go to TamTam Jam. TamTam Jam lets you have multiple instruments, multiple voices at once. It synchronizes over the network with the collaboration model I was describing, so you can have an orchestra, garage band. You can take the whole classroom and make music together. And in fact, the children in Thailand figured out they get their parents with the traditional instruments to come in. They're playing the computer, the parents are playing the traditional instruments. They have a community orchestra using TamTam Jam. Some children are going to go further. Some children are going to climb to the next ridge on the mountain. And that's TamEdit, which is a sequencer where they can start composing music and laying down tracks and making sequences. And some children are going to climb even higher. They're going to go to the synthesizer lab. Because with Sugar, we only give them a few hundred instruments. And they might want to design their own instrument. So that they can play with the synthesizer lab and play with waveforms and random number generators and different types of modeling techniques and create their own instruments. And share those instruments back to TamTam Mini or TamTam Jam or the sequencer, TamEdit. And then some children are going to even climb higher, because some children are going to be curious about, well, how does this all work under the hood? What is the representation of music inside of a computer? So inside of TamTam, we have a programming language called C-Sound. C-Sound is the same programming language that the professionals use. It's the programming language. Anybody who's serious about music and digital music, MIDI's the amateur stuff. C-Sound's the real deal. That's what the pros use. And so we go from what a 2-year-old can use right up to the same tools that the professionals use. And that's really, that's the idea. Low floor, no ceiling. Around every aspect of boy, oh boy. I'm not sure what's going on here. Don't let your computer fall asleep in the middle of your presentation as a lesson. You know what I'm going to do? Just, actually, before we do that, let's see if this is going to work. So, So sorry about that. The idea is that to make with everything we do with Sugar, not just music, but programming, writing, media, in every case what we try to do is provide this mountain to climb. And that not every child is going to climb every mountain, but the mountain's there to climb. So the opportunity exists no matter what you try to do in Sugar. The opportunity exists to climb the mountain. And my whole presentation seems to have gone wacko here. Let's see. We'll have to wait 1 second while this is recovering. I can do something else while it's... I'm going to just show you a little example of programming in Sugar, the kind of thing we do with the children, and again, to sort of show you a different kind of mountain that they can climb. This is a graphical programming environment called Turtle Art, and very simply, you take these little blocks, and I can tell the turtle to go forward, and I can tell it to go forward again. I can erase it. I can tell the turtle to turn right and right again. I can snap them together, and now I've got a little macro. Now it goes forward and right, forward and right. And if I repeat this 4 times, now it makes a square.